Alright, so here is the second part of 7.5. So the power property of logarithms. So what this says is if you're taking log base of something to a power, you can just bring the power out front. It's the same as taking the exponent, whatever the exponent was, times log of the base. Okay, a little confusing. So what I'm going to do is just go over some examples for you. Okay, so first, if I say something like log base 2 of 16. Now remember, this is the same thing as saying log base 2 of, so 16 is just 2 to the 4th power. I have an exponent, right? So let me bring the exponent out front. So this is the same thing as saying 4 times log base 2 of 2. Wait, log base of the same thing? This right here is equal to 1. So I have 4 times 1, so that would just be 4. This is fully using the properties of logarithms, right? This is an identity property, right? Because 2 to what power is going to be 2? Oh, literally 1. That's why this thing is 1. Logarithms, the answer is an exponent. Okay, so let's do the actual example. So log base 5 of m is equal to 1/3 log base 5 of 125. Ooh, so I'm supposed to solve this equation. So this 1/3 is going to be an exponent. So log base 5 of m is equal to log base 5 of 125 to the 1/3 power. Now that's just the cube root, right? So since I have the same base on both sides, I can set the insides equal to each other. M is going to be the cube root of 125. So remember from chapter 6, to the 1/3 power is the same thing as saying cube root. So m is going to be equal to 5, because 5 times 5 is 25. And if I take 5 to the 3rd power, if you have 5 quarters, you have $1.25, which is 125. So m is equal to 5. All right, let's do B. So the name of the game is I want to combine these two in terms of log base 3 of something. Equals, right, combine these two into log base 3 of something. Then, once I have the same log on the same side, same log base, I can set the insides equal to each other. Okay, so let's do that. Erase. Okay. So let's do the left side first. Ooh, so any coefficients, let's bring it up as an exponent. So I'm going to bring that 2 up. So I have log base 3 of y squared plus log base 3 of 0.1. Okay, this is going to be the same. This is going to be equal to log base 3 of 5 plus log base 3 of 2. And whenever you're adding two logs, it's the same thing as rewriting it with the insides multiplied. So this is just 5 times 2. And over here, this is just going to be log base 3 of y squared times 0.1. Since I have the same log base on both sides, I can set the insides equal to each other. 0.1 y squared is equal to 10. So if I divide by 0.1 on both sides, 0.1 divided by 0.1, I get y squared is equal to, okay, so if I have 10 dividing by 1/10, so 10 divided by 1/10 is the same thing as 10 multiplied by the reciprocal. So you get 100. And if I square root it, you get plus or minus. Right? Square root both sides, you get plus or minus 10. Now, the issue is if I plug in a negative, right? If I plug in negative right here, I don't want to be taking log of -10, right? Log base 3 of -10. You can't do that. That's why my answer is only going to be the positive 10. Because if I try to plug in log base 3 of a negative number, nope, no can do, goodbye, that's it. So let me tell you which ones we use. So right here, we use the power product. Over here on the right side, so first we use the power product. And then, right, on this line, right, to get down here, we use the product property. Okay, let's go down to C. So I have log base 7 of m equals 1/3. Oh my gosh, look at all this nonsense. So if it's a coefficient, you bring it up as an exponent. So now I have log, let me zoom in a little bit, run out of room. Alright, so I have log base 7 of m is equal to log base 7 of 64 to the 1/3 power plus log base 7 of 121 to the 1/2 power. Okay, let's just simplify a little bit. So this right here is the cube root of 64. What times itself 3 times is 64. 4. That's what it is. So log base 7 of 4. This guy right here is the square root of 121. That will just be 11. So I have log base 7 of 11. And over here, this is just going to be log base 7 of m. Okay, so this was using the power property. All right, power. And now I'm about to use the product. So I have the same base and it's adding 2. Okay, so that means I can rewrite it as multiplying. That was not very good English. So I can so instead of saying log base 7 of 4 plus log base 7 of 11, I can instead say log base 7 of 4 times 11. And on the left side, still log base 7 of m. And now that I have the same base on both sides, I can set the insides equal each other. So m is equal to 44. And that's rad because it's a positive number. I can take log of a positive number. We're all good. Solving exponential equations using power, quotient, and product rules. So we've kind of been doing this already. Let's take it a step further. Okay, so I need to combine these, but first I need to get the exponent up. So I have log base 2 of x to the 4th minus log base 2 of 5. I'm just going to rewrite the whole thing. Ooh, so if I have a minus, that means I can rewrite it as a quotient. So this will be log base 2 of x to the 4th over 5. And this will be equal to log base 2 of 125. And now that I have the same base on both sides, right? Log base 2, I can set the insides equal each other. X to the 4th over 5 is equal to 125. Multiply both sides by 5. You get x to the 4th is equal to 625. And then if I take the 4th root, literally putting each side to the 1/4 power, you will get x is equal to 5. Perfect. X is equal to 5. So we use the quotient, right? So this line we used the quotient, and then we used, first we use the power, and then we use the quotient property. Perfect. Alright, so I have the same base, they're being added, so what I can do is multiply these together. Log base 7 of 27 times 81. And over here I have a 2 as a coefficient, so bring it up front. Log base 7 of x squared. Okay, so I did 2 things in 1 step. However, now I have the same base, I can set the insides equal each other. So 27 times 81, you're going to have to do this in your calculator. 2,187. Alright, now we just need to square root. So solve for x. X is going to be 46.77. And keep in mind, technically when we take the square root, it's plus or minus, but we don't want the minus because I don't want to be plugging in a negative number right here, because you can't take a negative number of a logarithm. And here's the last problem. Okay. So I see a plus here, so that means I can combine these by multiplying x times x plus 5. Oh my gosh, this is so bad. So I'll write this as log base 6 of x times x plus 5 is equal to 2. Alright, now that I have a single logarithm, I can write it as x to the 6, I can write it as 6 squared equals, x squared plus 5x. Alright, I just distributed the x times x is x squared, x times 5 is 5x. So I have 36 is equal to x squared plus 5x. Move the 36 to the other side. So 0 equals x squared plus 5x minus 36. What adds to the middle multiplies to the end. Well, I'm just going to move up here. Okay, so 0 equals, plus 9, x plus 9, and x minus 4. Because they add to positive 5, multiply negative 36. Set each of these factors equal to 0. You see x is -9 and x is 4. I need to see, okay, which one can it not be? So for instance, you see right here, I just have log base 6 of x. I can't be plugging in a negative number, so that's not on the docket, and then we're good. This is all, x equals 4. So that's it for the second screencast, and then this is the last screencast before spring break.